All right, let's have a look at question number 2. We're told in a survey of 100 large corporations, 25 said that given a choice between a job candidate who smokes and an equally qualified one who doesn't, they would prefer to give the job to the non-smoker. Part A, we're asked to let P represent the proportion, and note to self now, right off the bat we know we're dealing with a proportion. We want a number. We want P is going to represent the proportion of all corporations preferring a non-smoking candidate. Find a point estimate. A point estimate is a summary value from a sample. We have a sample of 100 large corporations, 25 of whom said they'd prefer to give a job to a non-smoking individual. So our point estimate is simply going to be the sample proportion, which I've got right here. So P hat equals number of corporations who said they prefer to have the non-smoking candidate divided by the total number who were sampled. This is my point estimate. So this is the sample proportion. It gives me some idea of what the population proportion might be, but it certainly does not represent the population proportion. Now we're dealing with proportions. Part B says verify the requirements for constructing a confidence interval. So we're going to have to get a confidence interval for this population proportion. We want to know whether we've met these requirements. And let me see here now, because I'm doing copy and paste from some other thingy. Wait, now what's going on here? Okay, hang on. What are the requirements? The requirements say, first of all, that the corporations are supposed to be randomly and independently picked. So it doesn't say that in this question, but I'm assuming that this is true. Assuming I've picked them randomly and independently from all available large corporations, and my sample size is not supposed to constitute more than 10% of the population. And I would assume that 100 is not more than 10% of all possible large corporations that I might have. Now, there is another requirement that's pretty important for these things. And that requirement is, and I'm trying to copy and paste it from somewhere else. 1 second. Oh, it's being contrary. Okay, that is the success-failure condition. And success-failure condition says the number of successes, and 0.25, I got 25% of my sample is a success. A success in this case is whether or not the corporation would hire a non-smoker. So okay, I've got my p-value from my sample is 25%. I had 100 people, or 100 corporations, sorry. So number of successes out of 100 was 25, and this represents the number of failures. So these are the people who don't care whether you're hiring a non-smoker or not. 1 minus p is going to get me 0.75, and therefore I get 75 failures. And both of these numbers, the 25 and the 75, are supposed to be numbers which are greater than, greater than 10. So that condition has been met. Okay, we're good to go. Find a 95% confidence interval for P, where P represents the true proportion. And again, I'm copying and pasting from somewhere else. My formula for proportion says, and this time I'm saying it's a 95% confidence interval on P. How do we calculate that? We take a sample proportion, that's the p hat value, plus or minus the z-score. The z-score we use is dependent on the level of confidence, times the standard error of the mean, and this is the whole standard error piece when we're talking about proportions. And typically we're supposed to know the true population proportion, but of course we don't know that, so we are estimating it by putting in the sample proportion. So the number of successes times the number of failures, or sorry, the proportion of successes times the proportion of failures, 1 minus p hat, which your textbook calls Q, and so does a lot of other textbooks. All right, and okay, we got that divided by n. We got to take the square root of it, multiply by z, and plus or minus it from the sample proportion. So what do we know? We know our p-hat value, our sample proportion is 0.25. I'm going out plus or minus 1.96 because 1.96 is tied to a 95% level of confidence, multiplied by the square root of my sample proportion times 1 minus divided by my sample size. I work all this out, and it turns out that I'm 95% confident that somewhere between 16.5% and 33.5% of all large corporations would prefer to hire a non-smoker. So I've already got that typed out. Hang on now. If I do a copy and paste. Alright, trying to get things organized here. Hang on. So there's a couple of ways you could state this. I've said we are 95% confident that the true proportion of all large corporations who would choose a non-smoker from equally qualified candidates should fall between 0.165 and 0.335. Alternately, we could say that we are 95% confident that somewhere between 16.5%, oops, 5% to 33.5% of all large corporations would choose a non-smoker from equally qualified candidates. Okay, so I could do it either way. Now, coming back up to my question, we've just looked at A, B, and C, O, and D. E, what is the margin of error? And then in F, we're asked to find sample size. Now remember, margin of error is whatever number comes after the plus or minus. In this case, the margin of error is 0.085, and as I showed you on the first example here, we could also look at the margin of error from the point of view of half the distance of our interval. Our interval runs from 0.335 to 0.165. Find the difference between those two numbers, divide by 2, and there it is, but that corresponds to this number you should have calculated right here. Okay, so there's that. Ignore this business right here for a moment. I'll come to that. Now, the next part of this question asks us, if we wish to estimate the true proportion of large corporations who would prefer to choose a non-smoker, blah, 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 blah. If we wish to estimate the true proportion, correct to within 0.02. Now, the within 0.02 is telling me the margin of error to use. And it's telling me we want to make this estimate at a 95% level of confidence. And the question is, how many corporations should we survey if this is the case? So, similar to what we had in question number 1, and the only difference being here now that we're not trying to estimate samples, or we're not trying to get sample size to estimate a population mean like we did in the first question. This time we're trying to estimate a population proportion. So the formula is different than the one that I used in question number 1 here. All right, my sample size is equal to the square of the z-score that corresponds to a 95% level of confidence. That value is 1.96. It's asking me for some estimate of a proportion. We have a sample proportion, that's my estimate, 0.25 times 1 minus that value. And in the question we were asked, coming back up here, that we want to estimate it correct to within 0.02. That's my margin of error. That needs to be squared, and the 1.96 needs to be squared. The rest of it is not squared. Okay, stick all that in your calculator. Your calculator is going to give you 1800.75. You always have to round up to the next whole number, so you're going to have to survey 1,801 corporations in order to be 95% confident that your true proportion lies in whatever this interval is. And the width of the interval is going to be 0.02 times 2, which is 0.04. So this interval is going to be tighter than this interval up here. And to just illustrate a point here, assuming that my sample proportion was 0.25 and I go out minus 0.02 and plus 0.02, my interval would run from 0.23 to 0.27. That's a lot tighter interval, gives me better information, somewhere between 23 and 27%, than this one that I got up here, because this one here is a lot wider. It's not narrowing really down on the true value I want. This interval was based on 100 corporations. Whatever these numbers work out to be here, the difference between the upper and lower will be 0.04 as opposed to the 0.085 that I have up here. And of course, the reason this one is going to be narrower is because my sample size this time would be a lot bigger in order to do this, 1801. All right, I'm going to shut it off here and we will proceed with other parts of this question. Okay, one thing I forgot to do was to get the answer, by the way, to the confidence interval. Let's go to Minitab and get Minitab to get our answer for us. So hang on here now. All right, getting a confidence interval on a proportion, basic statistics, we want one proportion. And again, we can do a test of hypothesis or we can get a confidence interval. We don't have any raw data in this example. We have summarized data. We knew that 25 corporations would prefer to hire a non-smoker from equally qualified candidates out of a total of 100 corporations who were surveyed. We go to options. We want it to be 95% confident. Okay, we want to say not equal to. And by the way, if you want to get the answer that if you want to get the exactly correct values that you get from the formula that's in our book and in our notes, you have to ask Minitab to give you the normal approximation as opposed to the exact interval. Click OK and OK, and tells me that it's used the normal approximation. I've given it the 25 out of 100. It calculates my sample proportion, and here's my confidence interval. So if I copy that back into my assignment, say I stick it right here, then these values here do correspond to the ones up here that I've worked out by hand. Okay. Oops, sorry. Forgot to move this over. All right, now let's look at it. Here's the proportion we got in Minitab. Here's what we're getting by hand.